Okay, good morning, everyone. And I'm Lisa Amini, and I would like to talk to you about what we're seeing a little bit. First, I'll start with what we're seeing in AI, agentic and generative AI, and then I want to try to relate it to what we're doing within the enterprise. Okay, so first off, some numbers. Something that's happening that I think represents an important shift within AI is that it's kind of a changing time dynamic, right? So in AI, what we've always done is we've tried to measure the AI systems objectively by having benchmark data sets. That benchmark data set is designed to allow one to test against some task. That task might be generating code, answering questions, or whatever the case may be. And then what you're doing is to try to assess performance against those numbers. If the numbers are too low, then essentially the model is not useful. However, what we're trying to do is to try to, surpass human proficiency in these tasks, because if we're able to do that, then obviously the time that it would take for the AI model to do this would far outstrip the time that it would take for a human to do this. So some of these challenges are over 40 years old, right? So being able to do speech recognition, handwriting recognition. So you see these on the far end over here, and it took decades of investment and effort in order to try to reach this human performance threshold for those. But what you're seeing here on this side is that the time that it's taking between when we issue these new benchmark data sets, these new tests, and when we're able to surpass them with the AI is dramatically accelerating. And what's interesting is that these are much more challenging tests, right? So reading comprehension, for example, language understanding, these are much more challenging tasks to be able to do at human proficiency levels. I think even more telling is when you start to look at this and you zoom out and look at the time, right? So what actually happened, I'm sorry, I'm just going to try to be able to look as well. So what actually happened is that the glue, right? So this general language understanding, when that model first came out, we thought it was well beyond, or that data set first came out, we thought it was well beyond the capabilities that we had, but then we're quickly able to surpass that. They then came up with superglue, was the next one, and basically, again, able to surpass it. So you saw a bit of a change where we said, okay, we've got to make much, much harder benchmarks that we're going to go after. And here you can see, all right, much harder benchmarks in terms of being able to solve math problems, word problems primarily, being able to do multi-choice knowledge and reasoning types of questions, doing it across diverse domains. There's what they call big bench, which was thought to be beyond the imitation game, meaning beyond being able to just imitate what humans are able to do. Common sense reasoning, so very hard, very challenging problems. And what you're seeing is, quickly being able to approach and sometimes surpass. So these are being solved, which formerly was taking decades. We're now looking at a few years in some cases, and even a few months in other cases. So a dramatic change here. We are continuing. I mean, it's not like these are the only benchmarks. We'll continue to go after these benchmarks, continue to make them more and more challenging, more and more meaningful. But it is a dramatic shift that we're seeing. Okay. The second thing is this performance in AI most recently, especially, has been fairly predictable in terms of being related to progress in compute. So more powerful compute systems, data, being able to have more data to train the systems, and also algorithms. So the algorithms themselves, as they're getting better, that's where we start to see improvement in these. One of the things that you're seeing here is that, scaling laws where we were doubling compute roughly every 20 months, what you're seeing is now doubling within 6 months. This time frame, this 2010 time frame, is roughly when deep learning came about. And then this next big jump that you're seeing kind of over here is when the generative AI started to come about. So dramatic changes. We don't expect, unlike, one of the things that's different from previous generations is that we often see, these advances, and then we start to see plateau, right? And then it kind of goes from there. One of the things that's a bit surprising is that we're starting to get to the point where as we come to some plateau in terms, then we're able to figure out ways to kind of bump beyond it. So one of the first problems, if you looked at deep learning, we were trying to get very high quality data to try to train them. And then the big change that happened, in my opinion, because of generative AI was learning how to use lower quality data to sort of self-supervise these models, right? That was a big change. The change that you're starting to see now is that we're able to now use even lower quality data, and we're able to use it not just to train the models, but also to synthesize new data. So the data is not plateauing. The compute is not plateauing. We're continuing to bring more compute to this. The algorithms are continuing to advance. There's a lot of activity there. And it's actually even a surprising change as well, is that previously what would happen is that you'd see that sort of plateauing maybe as you reach a certain size of a model, right? But the surprising thing that's happening as well is we continue to make the models bigger and bigger, right? So originally, tens of thousands of parameters, and then hundreds of thousands of parameters, billions of parameters, hundreds of billions of parameters, and we continue to have useful and better performance from those larger models. So, and sometimes in surprising ways. So we feel that the scaling laws are continuing to shift, and this is going to have a major factor for us. The other thing is to try to measure innovation and maybe innovation by geographic regions. So one thing that we see is that the best models today, and in this particular thing, the number of highly cited publications in the top 100 publications, you see the U.S. is clearly ahead there by a large margin. However, if you look at AI publications in CS by select regions, I know one of them is a little bit faint. The one that's at the top is the largest is rest of the world, then it's China, and then Europe, and then the US. This is English language. If you look at English language and Chinese language publications in AI, then it's actually China, India, and then the US. So we're seeing a changing dynamic as well in terms of the rate and pace of research and innovation that's happening not just in the US but across the world. We should also be looking, I think it's important for us to look not just at the measuring AI by publications, by models, by benchmark performance, but we should look at productive real-world impact in the terms of automation and devices and deployment of AI. This is a measure of the industrial AI robots installed in the top 5 countries. So you see China way ahead, China, then Japan, and then the US. So we also measure deployment. We can look at medical devices. So the last one's not by geography. But what you're seeing here is you're seeing just amazing acceleration that's happening in the data, the model, the compute, the deployment, the devices. And so this is truly just an astounding time for AI. The rate of change, even as researchers, we're sitting here, we're doing the work, invested in the models, and then some new model comes out and we look at it and even we are saying, that's surprising. That's impressive, right? So I think this is a really different time for us, for the world, for AI and for automation. Okay, so now I want to shift and talk a little bit about in the enterprise, because I think probably most of the audience, has interacted with, ChatGPT, with being able to generate images on the web and so on. So we have a good idea, even if you're not an AI researcher, of how these new models are working and some of the impressive things they're doing. It looks a little bit different in the enterprise, and I thought it might be interesting for everyone to see what it looks like as we deploy AI in the enterprise. Okay, first off, the numbers again. AI is projected to enhance human productivity and unlock 16 trillion in value by 2030. So both of those numbers are astounding in my opinion. We expect these numbers, that increase at 16 trillion, to come from increased productivity and from secondary effects from that productivity and deployment and so on. So really big numbers in terms of the impact that we're having. It's not just the benchmark, but it's economic impact, it's business impact as well. All right, so I can talk specifically about what we're doing at IBM. We recently announced that AI and automation have helped us to drive 3.5 billion in productivity gains and reduced cost in the last 2 years alone. And this is by applying AI to us. In other words, this is not what we've saved by applying it to others. This is what we're saving by applying it to our own businesses. So this is significant. We see a fundamental shift in terms of how AI is deployed in the enterprise. First thing, generative AI was AI that can generate for you. You give it some natural language phrase, and maybe it generates an email for you, or it generates a report in some cases, but it generates an image, right? So this is the first stage. Second stage is AI that can chat with you, right? So it can interact with you. These are more like assistants, right? So it's trying to help me as a human to accomplish some task. I interact with it and it helps me to do that. The next stage, and what we refer to as agentic AI, is when we have the agents that are actually more autonomous. So in other words, they're not necessarily coming up with their own goals at this point, but what they are doing is they're coming up with the ability of how to solve problems on their own, as opposed to a human steering and telling it what they want it to do for them. So I think this latter one especially is going to be a dramatic change. The idea here is that we will see these systems that were both single agent types of systems and systems of agents, right? So I think now, and this is an important aspect of this, is we're going from models to systems of models to systems of agents. I find this especially fascinating because I actually started off in distributed systems, in networking distributed systems. And so now to see that AI is, not just the networks that are so tightly tied together, but agents collaborating, multi-agent working together to try to solve problems, I think it brings us into yet a new regime. Okay. Within IBM Research AI, we focus on three primary areas. We focus on building the models themselves. So Granite is our family of models. These are all open source, responsibly sourced data that we put out in that we make the model so that we can make the models available not only to our customers, but we also these are all available on Hugging Face as well. You may also know that IBM has a very broad set of products towards what we refer to as our data portfolio. So these are databases and knowledge bases and catalogs, warehouses, lake houses, BI tools. So just a very large portfolio that's centered on data. One of the third areas that we work on is, and our job as far as AI is concerned, is we're basically doing two things. We are infusing AI into those systems to make them more efficient, to make them more self-service, to make them faster. And then what we're also doing is we are trying to make them better for servicing these AI workloads, generative AI workloads, training, inference, workflows of that might be deployed through, RAG, assistants, and agents, and so on. And then our third big area is agents for automation. So you may have heard of SweBench, for example. So that's the ability from Git issues to be able, or a description of a problem in software that might have been filed generally in a Git repository, being able to take that and the code and generate patches to that code. So one of our agents is working on exactly that. SRE is about system reliability agents. So, in the business world, what you have is you often have large numbers of systems, and those systems have to be maintained by humans. They're looking at what are the problems, trying to solve those problems, and so on. So system reliability agent is really about being able to monitor these systems and resolve issues. Compliance. Right, so need to be able to ensure that the automation is working the way we expected, or even that our processes are working the way. FinOps is about saying, hey, look, I deploy all of my software onto these cloud systems. Turns out that, we're usually paying a lot of money for that, to run your database or to run your warehouse or whatever the case may be. So customers want to be able to look at what those costs are, how things are being spent and try to optimize their costs. So many different types of agents that can help us to run the enterprise, run the data center, run the systems, run the processes, and all of this. One of the things that we're doing is in the Granite models, what you hear a lot in the news is about the very large model, the hundreds of billions of parameter types of models. And that's an important area, obviously. But in the enterprise, what we see is that oftentimes you need to, even for those models, to try to work against the enterprise data and the setting, you need to have them actually tuned for that environment. So what we're finding is that in some cases with our smaller Granite models, so a 7B or an 8B model, sometimes a 3B model up against a 70B model, if we train or fine-tune the smaller model, we're able to get comparable performance and get it for much cheaper. So this is an important area. I think the story in terms of exactly how we use the large models and the small models is an evolving story. This will continue to change because there are huge expense not only with training these very large models, but as you deploy them and are running inference, it can be continue to cost a lot. Right? Okay, so this I thought this would be interesting. Very different from what you see on the web in terms of just chat or image generation. What does an enterprise assistant look like? So you can see on the far end there, we have different types of assistants. Assistants that help people that are trying to do procurement, digital sales, employee service, health insurance, sales agent, and so on. So all of these individuals, all these different divisions and departments across the enterprise, if you think about it, right, it's like, we have hundreds of that. I'm gonna let this, I'll kick this off and let it run a little bit. We have hundreds of thousands of columns, tens of thousands of tables. So, when you look at some of the databases that are on the web or the tables and so on, they tend to be small tables. They tend to be small numbers of tables. Within the enterprise, generally we would have, in our lakehouse, we would have tens of thousands of tables. We would have hundreds of thousands of columns. A table has millions, sometimes multiple millions of rows. And in the enterprise, sometimes you just want to ask a question, right? Just like, where is this customer? What is this customer buying? What are they doing? How can I build a strategy to try to engage with them and so on? And the people have to go and interface with many different systems. And if any of us engaged with sometimes just one UI, sometimes it's frustrating getting the information that we want out of this. So we've changed how we're doing that, and we interface through these assistants. So I can come in, I can ask it to help me to retrieve information, policy documents or documents about the products and so on. I can ask it to give me information about markets, so external documents as well. I can ask it to look up information in the databases for me. We integrate with tools, so it can then call the APIs to do updates against that, all on my behalf. And what's happening is that it's not just the ease of use. So now when I'm looking for something, I can just ask in natural language, and it's going to go to find it, and it's going to bring that information back to me, or it's going to go and do the task for me. But an unexpected benefit or an interesting side benefit is when we used to change from one platform to another. So, for example, we changed from one HR platform to a different HR platform. You had to train everybody in the company. You had to train the people who are going to manage it, train all the different users that were going to use it. Now the users don't see any of that, right? They just ask their questions in natural language, and it will figure out how to. And so we can basically change out entire subsystems beneath this, and no one has to know. So this is a big part of how we are saving some of that money that I was talking about earlier. Okay. I just want to kind of a little bit more on these AI agents, because sometimes when people refer to AI agents and assistants, they use the terms almost interchangeably, and they're not interchangeably. Think assistant, something that's helping me. Agent, think in terms of autonomous and be able to set its goals, being able to act on it, use short and long-term memory, be able to engage in many different tools. So what's a big problem that we can go after? An additional big problem that we can go after. So one of the problems that my team is working on right now is data ops. So In an enterprise environment, what you have is you have data modelers. They figure out what's the layout of data that you would want to store. You have data engineers. They build, SQL scripts, for example, ETL, Python, all these scripts that are going to make sure that the data flows. You have data stewards. They understand what data their department needs. They're going to bring that in. They're going to vet it. They're going to make it ready. So you have literally an army of people who are really trying to manage what we refer to as the data estate. They're trying to make it end-to-end in terms of the efficiency of the data. They're trying to ensure that it is secure and compliant, and they're trying to lower the costs both of managing it as well as of interfacing with it by making it much more self-service, both in terms of the access as well as management. So one of the things that we're working on right now is what we refer to as agentic data ops. And the idea would be to have semi-autonomous and autonomous agents that can collaborate to manage that data estate and do it seamlessly across structured and unstructured data. Okay, so I'll start to show you what this sort of looks like. So normally what would happen is that someone can come in and they would want to ask for the data, and that's what you saw on the other ones. In other cases, the data is just not there. Or one of the things that a lot of people don't realize is that when they ask a question and then we go and try to generate the SQL to get the answer for them, if I'm having to pull from many, many different tables, if I have to go find many, many different tables, pull from many, many different tables, figure out how that's, the generators of today, the SQL generators of today simply aren't going to be able to do that. So in many cases, we have to pull that data together first, further curate it, and then make it available for the RAG workflow or the agent or the assistant to go against it. So, okay, so this is just going to kind of show that in addition to being able to just ask for the specific points that I want, can I ask for the data that I want, right? So in this case, I'm saying, hey, can I get some information? I'm looking for information on investment strategies, mutual funds. I want to be able to understand risk. I'm going to have to query it in terms of analytics and want to do SQL for it and so on. So we had our agent. It's out there. It's listening for these new requests to come in. First thing it does is it generates a plan. It says, okay, you asked for this data with these different properties. I got to figure out how I'm going to solve this. So it first generates a plan, asks the human, or it could do this on the own, depending on how you've set it up. Ask the human, do you like, this is my plan. I'm going to go and get this data. I'm recognizing that you want this to be able to access it with SQL. I'm probably going to have to do some extraction from unstructured sources to get you that. You want me to go ahead? Yes, please go ahead. So then what the agent is doing is it sort of imagines the target schema that it would want to have to fully answer that request, imagines that schema, then it starts going into the lakehouse and trying to find that and associate it with those fields. And then it starts looking at those fields and it starts extracting the structured information from unstructured so that I'm going to be able to hit it with the SQL queries. And then basically it updates the get issue with, okay, this is what I found, these are the different fields, so it's able to track all of that information. So now I have a system where it's going back and forth and it's working essentially as part of the team. It's working in the background and doing these tasks for me. And it can engage the human when it wants, or the human can decide when it wants to do that. As another example, you may have, if the agent generated the data product, how do I know it's a good? How does the agent know that it's a good data product? Okay, well, we can also use agents to start to assess it. One of the things we want to do is we want to see whether or not the insights that I could get from that data product matches. So I can take the description of the data product that was desired. I can take the new schema, that hypothetical schema, that target schema that I created and then populated, and then I can generate natural language questions that I think would be likely valuable questions to ask of this data set. The agent can then generate the SQL for that. It can execute the SQL against the database, and then it can look at, okay, for those, how many of these succeeded? Human can interact with this. It forms a record of, not only what's working with this. So when someone else comes to look at this data product, they can even see, okay, what kind of questions could I ask? What kind of applications could I build on it? So all of these artifacts are being generated by the AI, by the agents, and then the humans are able to follow along and intervene if something gets stuck. What can also happen is that, as you probably noticed, when some of those queries were being executed, some worked, some didn't work. So the agents are also, you wouldn't want the agents to go and try to pick off those problems one by one. Instead, as humans would do, you sort of cluster them together by symptom, and then you attack the symptom. So the agent then looks at a particular symptom class. You can ask it to, or it can generate a plan to both to diagnose the issue and to generate a remediation script that you can then run against that, remediates the issue, and then it can validate against that issue. So the first set of assistants and agents that you saw, that's in deployment. Those are working. Thousands of people are hitting those. Thousands of people are hitting those every day. This is in research, so not yet in deployment, but something that we're obviously is maturing quickly. Okay. One of the things that we are finding is that the reasoning and planning skills of these large models, and this is a problem that many people are seeing, still needs a lot of effort. So we've been investing in especially trying to improve the reasoning skills that ensure they can do better planning. Okay, and we take on a variety of different approaches. We look at, okay, can I use the LLM directly as a planner? Could I use it as a policy generator? Can I use it to search for components that I could then put it into a plan? Can I generate a plan description logic for this? So we've created a new benchmark, ACP bench, action control and action chain and planning benchmark. You can get that from Hugging Face, which we're able to show by taking traditional planning problems, generating synthetic data around that, and then training the model. We are getting plans that are more closer to what we would expect in a computer science world, so less of kind of a chain of thought that many of them produce today, and more into a sound and complete plan, which would normally be pursued in a computer science. And then what we're able to do is, with that better planning, we can use it for improving our ability to tackle these complex data operations issues. Okay, so try to give you first a picture of what's happening in the field, the advances that we're seeing. Second, what does it look like in the enterprise? And then, okay, where is this going? And I thought it would be especially interesting maybe to look at some wild cards of where things are going. So I think one of the first things that I would say is sort of a wild card in all of this is quantum computing. Today, there are some efforts between, AI on quantum computers, but, the quantum computers, frankly, aren't really there in terms of, the ability to tackle some of this AI challenges, even in hybrid settings. But that's something that these are both running in parallel, and I think at some point that could cause yet another inflection point down the road. Another possibility in terms of a wildcard is data center energy. So we are consuming energy at an astounding rate. I read somewhere that the daily energy consumption of just inference, not training, inference for ChatGPT is on the order of the energy consumed by 180,000 households. This is just inference, not training, right? So we are consuming energy at a rate that is surprising. These large hyperscalers are starting to look at, fusion, buying into and investing into nuclear energy and so on. So what will happen with data center energy is likely a wild card in all this. Could be another inflection point that we could see in the progress of AI. The next one is enterprise data. So you saw me, showing these agents working on enterprise data. We estimate that approximately 1% of all enterprise data is actually being used with AI at this point, right? So we're able to get to such a small amount of that in terms of both training and even in these workflows. That's rapidly changing, I would say, with the RAG workflows, the agents, and so on. But at a 1% level, this could be a wild card once we're able to much more comprehensively access and leverage the enterprise data. And then the last area is AI applied to AI research. Could also be an inflection point for us, right? So if we're able to actually use AI. So right now, what you see is AI against generating code, right? But this is code that's, more prescriptive, I would say. If we're able to suddenly think about how we might use AI to hypothesize what the experiment should be, to be able to conduct those experiments, to generate the code, generate the models, to explore those. This could also put us in a very different regime. So I think I think my perspective on this is it's a very exciting time. It's a very tiring time. We're working really hard on all this, and it seems that every day, things that we thought were true just a few weeks ago are changing. But I think that it's there's still a lot to go. So that's what I had to talk about. I don't know if we have time for questions or yeah. Okay. Pleasure.
Hi, I'm Corey Fackleris from UNC Charlotte, a colleague of Mary Lou Mayer. One question we have, and I'm sure a lot of people have the same question, given all of this and what you can see from enterprise research side, what should we be teaching our computer science students going forward? What kind of jobs, what kind of skills will they need?
All right. Yeah, that's a very good question, right? So, okay. So one thing that I think is, I'll give the first obvious answers and then kind of go back. I think that the obvious answers are it's really critical for these students to keep up with all of these frameworks, that they are experimenting with the latest in terms of the models, the agentic frameworks, all of these sorts of things. They just need to know it. It's sort of like when I was going to undergraduate, there wasn't much. It's not that they taught us every language. They just said, look, you have to learn what it means to program, and then you've got to learn all the languages, and you just have to do that, right? So they absolutely need to be immersed. They need to be working on it. They need to be hands-on. I think another thing that's probably extremely important, as much as possible, is if the students can spend some time interning in computer science roles. I think that's a really big win. We can tell when we hire, PhDs, so we're about 75% PhDs and about 25% non-PhDs. And so when we hire a PhD, we can tell the ones, who've been interning. In fact, that's one of the things we do. We often they intern with us several times before we hire them, right? So I think the interns is critical. Interning and working on real world projects, open source, is huge as well. I think the other thing that I would highly recommend is could we get more skills in experimental design? I feel like that's not I feel like that should be a rigorous curriculum of what they're taught, because frankly, that's most of what we do, right? We're always trying to figure out, like, what is the experiment that's going to give us the most information, but minimizing the amount of time, minimizing the amount of compute that I have to spend on it. And this just keeps ratcheting up. I mean, these are very expensive experiments that we are running. They're time consuming. They take a lot of people, a lot of engineering, a lot of compute. So one of the things that I'm always trying to advocate for is more in the experimental design. Thank you.
Mark Hill, University of Wisconsin Emeritus and Industrial Consultant. So what is industry doing to make the case for deep research in government these days, right? Because the funding is in crisis, and when academics argue that we need to continue research funding, it's a little self-serving. So we need you guys to advocate for us.
We actually are, right? So I don't know if that's maybe we're not as as visible as we should be in doing this. I gave a talk yesterday as well, specifically for this, to try to raise the level. We have people within IBM that are trying, reaching out to government agencies, not just the agencies that fund us, but also the agencies that NSF. For example, generally doesn't fund industry, but we're reaching out, to NSF, to all of these, to try to help with that. So we see it as absolutely critical, right? It's very clear, right? I think the advances, I should have said it, the advances that you saw, the numbers that you saw against those benchmarks, those absolutely could not have happened had it not been for the NSF research funded in academia, the DARPA, grand challenges. All of these things, are what we continue to build on, right? It's even more stark than that, right? Like, where will we get students? Where will we get, the people that are going to work with us as researchers? If we're 75%, PhD and 25%, if there's not that funding there to drive the research. So we see it. We are reaching out. If you have ideas of more things that we can do, there's the policy part of IBM that does some of that. I'm not the policy part, but in terms of things that we as researchers can do, we're happy to do that. We are doing it as we're seeing the opportunities, but happy to do more.
Lisa, thank you for the great talk. My name's Victor Zhong. I'm from the University of Waterloo. My research is on agents, especially NLP. We've developed some of the benchmarks over the years, like WikiSQL Spider, Spider2, that your colleagues might have used. I'd love to kind of know more about what you're doing, but I think one of the questions that I have is when you deploy these systems in the enterprise, can you talk a little bit about how much trust the users actually have when you abstract a lot of the decision-making into these agentic processes?
Yeah, it's a good question, right? So, and first off, thank you for, we engage with, Spider, Spider2, Bird, these are ones that are very important to us. We do some on the leaderboard as well, but we also need to work on the enterprise data, which is a little bit different, but the benchmarks are a big deal for us. So, in terms of the what we're seeing that's different in terms of the trust, it's kind of I would say that for some of the things that you were just seeing, in some ways for the assistant, it may be a little bit too much trust. Because like for that assistant, it's bringing the information to the individual. The first demo that I showed, where you're asking for the market information and the client information, things like that. These are going to people who are execs, who are business people, who simply don't have any way to really check this. I think that one of the things that we do is we've also tried to make attempts to, show them, okay, what was the logic? How did I get this? And these sorts of things. We don't see them clicking on it very much, right? So that tells us that, maybe they trust it. However, what I would also say is that, I would say that for those, they're sort of in a trust but try to verify kind of way. Okay, does this sort of make sense to me? Maybe I can go out and look on the web. Why didn't it do this? Maybe I can engage with it, tell some more information. But I would say for the assistants, pretty good. For the agents, that's where I think that we'll have to see, because, some of the things that I was just showing, do I truly expect that a data engineer will look at, it might look at a small segment of code, but what if I'm generating, 10 pages of code? Are they going to look at it? Are they going to trust it? So I would say it's probably a little bit less trust on the engineering and technical side at this point, and probably a little, maybe too much trust on the business side of it.
Thank you.
Thanks.
Ben Schneider. Ben Schneider, University of Maryland.
Hi, Ben.
Here?
Yes.
Okay. Thank you for this illuminating talk. Full with good energy, and there we are. Positive expectations. I think many people in the room are concerned, though, about some of the dangers and downsides, and so these have long been discussed. And could you tell us a little bit about the efforts that you're putting in place to deal with the known problems of hallucinations or fabrications or failures or errors, and the ways that these systems fail, and the way you collect and report the incidents? Furthermore, the sort of widespread use by malicious actors for misinformation, for terrorist activities, and so on. Yeah. Many of these scenarios have been played out, and I think they need to be filtered in if we're going to have a system, an approach that we're proud of when we're done, because the current systems are, frankly, leading us to a dangerous situation. They're startlingly impressive, but alarmingly flawed. And unless we address those, I think we are risking the future of our profession. I agree with you. So a couple of things. So we're doing it on multiple fronts, right? So on one front, as I said, IBM does try to get involved with and make our views available on policy. On policy, what we're advocating for is to say that, it's especially important to regulate. Policymakers need to do more in both understanding the AI as well as doing more work to regulate the risks, the deployment, the uses of AI, because
it's hard to look at the risk just from the model, but you can certainly understand how deployment scenarios could present problems. It should, deployment in terms of misinformation, bias, all of these sorts of things. We try to add.
Beyond that, I think within the model building and the system design and the interface, I think there's an obligation to make a responsible set of decisions.
True. Yeah. So yeah, I just wanted to kind of cover that. We do that. We try to do it by saying, okay, look, don't regulate by, going against, openness. We think opening AI, two words, are important. We think responsible deployment is important. Don't try to stop the deployment. On the models themselves, we actually do a lot there. So one is more responsibly sourcing the data is one piece of it, right? So a lot of times when they first started out, there was data in there that just shouldn't have been in there. IBM invested a lot in that. Second thing that we've done is you can look and see there's what we refer to as our Granite Guardian models. So this is basically trying to tackle, can we have models that do more in terms of not only better models, but also can they do fact checking? In fact, I'll give a shout out to Kush Varsany, who is leading that effort. It's a significant effort, both to make the models more trustworthy, to tackle some of the hard problems, make sure that there aren't the issues, as well as guardrails, as well as fact checking and all of these sorts of things. So we do invest in it. And frankly, the other thing that we have been saying is that I think that I personally believe there needs to be a lot more investment, and we talked about this, NSF, academic, in AI safety and security. So not just security, but AI safety. I think this is a challenging area. So I'm agreeing with you. We are investing in it. Are we doing enough? I don't think we are, to be honest with you. Yeah. Okay. Sounds good.